Good morning all. This is the Jackery Explorer 240 portable power station. And while you might have seen these before, you won't have seen this version because it has a UK mains outlet for the 200 watt pure sine wave inverter. So this is a bit of an exclusive because today, March the 17th, is launch day for this product, or this version of the product, on amazon.co.uk. And there are links to this item and more on amazon.co.uk and amazon.de in the description box below. So what is this thing? Well, it's a box of lithium-ion batteries with an input so that you can charge those batteries either from solar or from a mains adapter, and various outputs, 2 USBs, a UK style mains outlet, and also a 12 volt 10 amp accessory socket or cigarette lighter output. It also has this display which I can switch on with the display button, but it's got this sticker over the top which I've been wanting to peel off for several days, so let's get that peeled off now if I can. Oh, it's quite sticky. It's very sticky. But there it is, and there's something written on here. I want to have a look at that. Okay, it says Jackery Power Outdoors. LCD display will be entering power saving mode in 15 seconds. Press display button to check the battery status. So let's do that. And currently the battery is at 89%. We've got no incoming power and we've got no outgoing power. Now, as well as being a box of lithium batteries with inputs and outputs, this thing is also an interface. It's an interface between a solar panel, and Jackery do their own branded solar panels in this same sort of grey and orange colour scheme. A solar panel which on its own you can't really do a lot with, and conventional output types, which is what we really want, 12 volts, 240 volts and 5 volts. So this acts as the interface. Now, if the solar panel is producing more power than you need, the difference goes into the battery. If the solar panel is producing less than you're drawing from the outputs, of course, that additional power comes out of the battery. So this is an interface unit. Accessories supplied with the Explorer 240 are these. A really heavy duty looking car accessory plug, springy tip, to 7.9mm by 0.9mm pin type socket that fits in the input socket of the Jackery, and also a power supply with a UK style plug on it, although that is a figure of 8 socket on there, and that is also terminated in the same 7.9mm plug. This power supply is a 100 to 240 on the input. The output is 19 volts, 3.42 amps, 64.98, let's call it 65 watts. Right, let's plug something into this. I'm going to plug in my phone, charge it up, that way around. Now to turn on the USB, I just press this button, little green light comes on, and the display comes on, and it's showing that the phone is not drawing any watts as yet. That's creeping up, 3 watts. Now drawing 10 watts. Now these are just regular 5 volt, 2.4 amps per outlet USB type A's. Right, let's do the first stress test. I've got a DC load here and a monitor here. 1 amp, 4.9 volts. Let's turn that up to 1.5 amps. Still 4.9 volts. Let's turn that up to 2 amps. Still 4.9 volts. The fans come on my load. Let's keep going. This is rated up to 2.4 amps. So 2.4 amps. It seems fine at with 4.8 volts. Let's wind it up further, 2.6 amps. And that's switched off, so I presume the USB output has shut down. The light is still on. And if I back off the current setting, then the USB port immediately fires up again and can produce 2.4 amps. and it's holding about 4.8 volts, so that's pretty good. What's it saying in terms of watts here? 12 watts, and this is saying 11.4 watts, which it might be actually because of losses in this cable. It's quite a thick cable, but there will be losses nonetheless. So does the Explorer 240 have overpower protection on the 12 volt output? Well, let's find out with this heater fan. I'll set it to fan for the moment. Switch on the 12 volt output. Yeah, that's come on. Let's turn it to heat. Is it producing any heat? And what's the display going to say? 143 watts. 161 watts. Well, it seems happy to produce that. 165 watts. It hasn't actually gone into overcurrent protection. 169 watts. 70. That's quite impressive. So the question that arises is, does this have overpower protection on the 12 volt outlet? Now it has a soft switch, so I presume there is the electronics to be able to cut this socket out, but is there the overpower or overcurrent measuring circuitry? And stop press, this electronic load turned up today, so I'm just doing a test on the 12 volt accessory socket output. Oh, put my finger in the fan. So I can wind this up to pretty much about 15 amps, I think, on the load. Let's keep that pressed. And I've seen 200 watts on this display here. Now that's more than that heater fan was taking. But the trouble is it goes over the 185 watts maximum on this unit. So let's just see if I can get that 15 amps. 175 watts here. 199. Okay, so that's about as far as I can push it. 14.9 amps, 12.3 volts, 200 watts on the Jackery. Right, let's turn our attention to the AC outlet. So here's my scope meter. I'll turn on the inverter and we can see that we're getting 230 volts AC. Let's switch that to scope mode. And there is the pure sine wave. Well, it's certainly a sine wave. The purity is difficult to tell because it's quite a coarse resolution, but if I press the up and down buttons, we can see it at different frequency rates or scan rates. Interestingly, the display here is saying 9 watts. So is there a power overhead simply running the inverter? Because this isn't going to be drawing any power at all. Right, let's do some power overload tests on the AC. So I'll turn on the AC. Oh, that's 150 watts plus 100 watts. That's 250 watts. What are we showing on the Jackery? 230 watts. And that is over the regular maximum. 232 watts, and it's sustaining that, so that's interesting. We're going to need a bigger bulb. I think I've got another 150, and this test with two 150 watt bulbs. Let's switch that on they come. So that's 300 watts. Let's take a look at the display. 50, 100, 150, 200, 250, 270, 280. Well, that's actually holding 285 watts, which is interesting. So this must have an overload percentage which it can handle. Oh, and it's gone out. Okay. So yes, it can't quite handle 300 watts. But that's pretty good. It handled 250. So let's test the 400 watt surge peak. I've got 150, 150 and 100. Let's switch those all on. So that's the 400 watts. It can provide peak power. It doesn't do it for very long, about 5 seconds, but that's what you'd expect. Good. Let's see how long it will sustain the 250 watts. That's 150 and 100. It's reading on here 239 watts, about 240 watts. And I'll see how far down the percentage indicator comes. It's currently reading 78%. Just leave that for a little bit. Well, it's held a consistent 235 watts, and I've brought the battery percentage down to 70% now. So it looks like it can sustain 235 watts pretty much indefinitely. And I'm not sure what happens when the cell voltages get a bit lower, because of course there'll be more current involved at that point. But up at the upper end, yeah, it's happy. And after that sustained test, I thought I'd have a bit of a sniff on the output. Doesn't smell like it's getting hot, but it's pretty warm up here, right up there, just above the vent, which is an interesting place for it to get warm. It's not really warm anywhere else. And this is the Jackery SolarSaga 100. It's a 100 watt, 18 volt folding solar panel. And when it's unfolded, it looks like this. Now, if you count the solar cells, there are 16 on each side. So this is a 32 cell solar panel. It's really easy to open this folding solar panel. Rather than a whole load of buckles and straps, it's just got two magnets. So it's simplicity itself to open it up. In the pouch on this side, we've got the cable which comes out of a terminal block here, and that also has USB type A and USB type C sockets and a little green LED. Now this cable is terminated for Jackery products in this 7.9mm outer diameter with 0.9mm pin plug, not MC4s, which most folding solar panels have. And the details here are that USB-C is 5 volts up to 3 amps, USB-A 5 volts up to 2.4 amps. And here's the Jackery Explorer 240 connected to the SolarSaga 100 solar panel. And we've got a reasonable amount of sun. Let's check the display. And I'm getting 68 watts. Now, interestingly, I'm also charging a USB-C power bank from the USB-C output on the Jackery's connector block. But if I unplug this power bank, then the additional power into the Jackery is only a couple of watts. So it's limited by something, and I'm suspecting voltage, but I can't be 100% sure. So now I've connected a monitor on the USB-A, and I'm pulling 12 watts from the USB-A, and at the same time I'm getting 66 watts into the Jackery, so that means I'm now getting 78 watts. So there does seem to be some limitation inside the Jackery which limits the input power, which the solar panel can provide because it's doing so with this additional 12 watts from USB type A. The most I've seen on here without the USB load is 68 watts. So with the 120 watt solar panel, 36 cells, I've also got this 150 watt bulb on the inverter output, and you can see that I'm pulling 147 watts, so the state of charge of the battery will actually go down because there's 67 watts coming in from the solar panel. 120 watt solar panel into the Jackery Explorer 240, and at 25% state of charge we're developing 64 watts into the unit. Now, another couple of points about this. Pass-through charging. Yes, you can connect an input and an output simultaneously. You did see it in the previous shot with the 120 watt solar panel briefly. The other thing I wanted to mention is that the input, you can connect the solar panel, and when the sun comes up, the unit will automatically switch on and start charging. I think that's also very useful. So to sum up, what do I think of the Jackery Explorer 240? Well, despite this thing's small size, it's quite a beast actually. You can overdrive the 200 watt inverter to around 250 watts continuously. It will run at 400 watts for a few seconds, so it can handle a surge current on an appliance which then has a steady state power consumption of 200 watts, or 250 I suppose. The accessory socket I've driven at 15 amps, and although it didn't show in the video, I did get it to go into over power protection or over current protection, so it does have over current protection. The USBs, I tested one of them, I didn't test both actually, and that does overcurrent at 2.4 amps, so that's fine. The only issue I had is I couldn't get 100 watts out of the 100 watt panel into the Jackery. The maximum I saw was actually about 70 watts with a bit of cloud edge effect. And it's not an issue with current, because I put a 100 watt panel in here, a different 100 watt panel, a 120 watt panel, and in fact I did a 160 watt panel. I didn't film that, and we've had very little sunshine recently, so I couldn't get that one on film. But that didn't change the amount of watts that this was pulling in. So this is a voltage issue. I think this unit will only pull in 100 watts if the voltage on the input socket is sufficiently high, and you don't get that sort of voltage from these 100 watt panels. Now you could argue that if you pull a bit of power out of these USB-A and USB-C sockets, that with the Jackery charging at about 70 watts, I think you could pull around 25 watts out of these two combined. So that is 95 watts. Now Jackery also do a SolarSaga 60 solar panel, which might actually be a better match for the Explorer 240. But this 100 watt panel might actually work perfectly well with the next model up, which I think is the 300 watt hour unit. I don't know, perhaps I'll find out in due course, who knows, but that's my findings on these two units. So cheerio.